Evaluating functions. Function notation. There are numerous ways to represent a function, including set notation, a map, a graph, a table, or an equation that relates the variables x and y. Function notation is as follows. For a function named f, the notation f of x is the value assigned to the input x. The letter f names a process, an input-output device that assigns to each allowable input x an output or a y value. So if you put a value in here for x, you will get out a y value, or f of x output. So in this example, we're given that f is a function that is a set of ordered pairs. Evaluate f of 1. So that means that the x value is 1, and we want to know what the y value is associated with 1. So when you put in 1 into the x value in this function, you get 2 as a result. All right, when you put in 2 as an x value into this function, 2 as the x value, you get 4 as the output. Which input x produces the output of 6? So if you want the output 6, you would put in an x value of 3. All right, here's another example. So given a function map, evaluate f of 0. So what that means is 0 is the x value here. So if you put 0 into this function, what do you get out of it? You get -1. All right, and if you put 3 into here, you get an output value of 0. Here is an equation example. Given the function defined by f of x equals 3x plus 2, evaluate f of -1. All right, so we're just going to plug -1 into that function, which means anywhere you see an x, parentheses, -1, and then simplify. So 3 times -1 is -3, plus 2 is -1. All right, evaluate f of 3. So f of 3 is going to be 3 times 3 plus 2. That is 9 plus 2, 11. Given the function f defined by f of x equals 4x plus 1, evaluate f of 2. All right, so f of 2 is going to be 4, there's an x, so I put in parentheses 2, plus 1. 4 times 2 is 8, plus 1 is 9. All right, next, f of 5. 4 times 5 plus 1. That's 20, plus 1 is 21. Next, f of -2. So we have 4 times -2 plus 1. That's -8 plus 1 is -7. And finally, f of 0. F of 0 equals 4 times 0 plus 1. Well, anything times 0 is 0, so we are left with 1. And there we have our answers. Solving for input. To solve for input means to find all of the x values that produce a given output y. Set notation example. All right, given f is a set of points, what we're going to do is move backwards. So solve for x. F of x equals 1. So if the y output value is 1, all we do is go and look to see where the y values are 1. And in this case, it's here. So the answer, the x we're looking for, is also 1. Solve for x. F of x equals 4. All right, so the y output value is 4. So let's look in our points. Here, the y value is 4. So the x value that gave us 4 is 2. All right, solve for x. F of x equals 9. So the y output value is 9. Here we see 9. the x value that gave us that 9 is 3. So 3. Here's another example using mapping. All right, so solve for x. G of x equals negative 2. So the output value is negative 2. So we go here and we see negative 2 is here. And what input value gave us negative 2? Negative 1. So that's negative 1. Solve for x. G of x equals 0. So if the output value is 0, here's our output values. There's 0. Which x input value gave us 0? That is 3. Solve for x means to find the inputs. So we're kind of just moving backwards from what we were doing before. Now we're given the outputs and we just need to find the inputs.